Today I'm going to show you layout design for an inverter. To make it easier, I'm putting side by side a stick diagram and schematic with the layout that I'm designing right now. So first I am putting the rails for VDD and the ground. Now let's put the instances for the PMOS and NMOS layouts. So I am putting the instances for NMOS and PMOS here and here. You can create it by yourself just using the same layers. As you can see in the schematic, the width of the PMOS is 150 nanometer. So we are going to edit the properties and change it to 150 nanometers for the width. Now I'm going to place the NMOS and PMOS and align them properly. As you can see, the gates are connected together for the input, so we are going to place polysilicon and connect the gates for PMOS and NMOS. Also, the drain of the PMOS and the source of the NMOS are connected for the output, so we are going to use the metal one and connect them together for the output. One of the important things that you can see in the schematic is the body bias. The body of the PMOS is connected with VDD and the body of the NMOS is connected with ground. So I'm putting nwell in the PMOS side and pwell in the NMOS side. So I'm going to put an active layer and an implant on the PMOS side with a size of 90 nanometers. So let's put a metal one and connect the body of the PMOS with the VDD. Now let's put the contact with the size of 70 nanometers. And for the NMOS, we are going to do the same thing and put an active layer and a P implant to connect with the body. Now we need to add the pins for different terminals. Let's create a pin for VDD and we can create a label and we can use the height as 0.05 and IO type as jumper. Now let's put the pin on VDD and I'm going to do the same for all other ports. I also need a contact for the input so that I can connect the metal with the polysilicon and make sure the label for the pins are on metal 1, not text. Now let's run the LVS and see what is the output. As you can see, there are some errors, and if you look closely, they're actually coming from the ground and the VDD are not connected properly. And if you compare the stick diagram, as you can see, the VDD is not connected with the PMOS in here, so we are going to add a metal one and connect the PMOS with VDD. And also in the NMOS, it's not really connected with the ground, so we are going to add a metal one. And now let's run the LVS and see if it's working. And boom,